Okay. Now let us discuss the properties of inverse trigonometric functions. Now first type property, prove that the following first one is sin inverse x plus cos inverse x equals to pi by 2. X belongs to closed interval -1 to +1. Second one is tan inverse x plus cot inverse x equals to pi by 2. X belongs to R. Now third one is cosec inverse x plus sec inverse x equals to pi by 2. Here mod x greater than or equal to 1. Now let us prove one by one here. Now first one is first property, sin inverse x plus cos inverse x equals to pi by 2. X belongs to closed interval -1 to +1. Now here take sin inverse x equal to theta. Take sin inverse x equal to theta. Take it on called equation number 1. Now further simplify. Now this implies x equals to this sin inverse, move right hand side, it become sin theta. Inverse trigonometric functions move right hand side, it become trigonometric function. मीन्स यहाँ पे क्या होता बोले तो इनवर्स ट्रिग्नोमेट्रिक फंक्शन राइट हैंड साइड को मूव किए तो उसका इनवर्स खो जाता है. नेक्स्ट अगेन सिंप्लीफाई, x इक्वल्स टू replace the value for sin theta. So sin theta value is cos pi by 2 minus theta, because cos pi by 2 minus theta equals to sin theta. We know in place of sin theta we put cos pi by 2 minus theta. Now further this cos function move left hand side, it become cos inverse of x is equal to what's remain here, pi by 2 minus theta. Take it on called equation number 2. Now adding equations 1 and 2, adding 1 and 2 we get add LHS and RHS separately. So equation 1 LHS is sin inverse x, adding means we have to add. Equation 2 LHS is cos inverse x. Now equals to equation 1 RHS is theta, we have to adding means plus. Equation 2 RHS is pi by 2 minus theta, means pi by 2 minus theta. So here plus theta and minus theta get cancelled out. So finally therefore sin inverse x plus cos inverse x is equal to what? Pi by 2. Hence the proof of first property. Now same case, let us we have to prove the second property, that is tan inverse x plus cot inverse x equal to pi by 2. Write down second property, tan inverse x plus cot inverse x equal to pi by 2. X belongs to R. Same case here also you have to take or take tan inverse x equals to theta. Take down called equation number 1. Next again this x keep as it is there only. This tan inverse function move right hand side, it become tan theta only. Inverse trigonometric functions move right hand side, it become trigonometric function. Finally x equal to tan theta. Further we have to replace the value for tan theta because we have to prove pi by 2 here. Means x equals to cot pi by 2 means 90 degree. Cot pi by 2 minus theta equal to tan theta, because as we know cot pi by 2 minus theta equal to tan theta. Same case, replace in place of tan theta cot pi by 2 minus theta. Then again this cot function move left hand side, it become inverse, that is cot inverse x equal to pi by 2 minus theta. Now take down called equation number 2 here. So then we have to add equations 1 and 2. Adding equations 1 and 2 we get same case, add LHS and RHS separately, that is tan inverse x plus cot inverse x equals to theta plus pi by 2 minus theta. Then plus theta minus theta get cancel out. Tan inverse x plus cot inverse x is equal to what? Pi by 2. Hence the proof of second property. Now same case we have to prove third property, that is cosec inverse x plus sec inverse x is equal to pi by 2. Now third one is, that is cosec inverse x plus sec inverse x equals to pi by 2. Mod x greater than or equal to 1. Now this implies take cosec inverse x is equal to theta. Take down called equation number 1. Then x is equal to this cosec inverse move right hand side, it become cosec theta. Again replace the value for cosec theta. So sec pi by 2 minus theta is equal to cosec theta, because cosec pi by 2 minus theta is equal to sec theta. Now finally this sec move left hand side, it become inverse, means sec inverse x is equal to pi by 2 minus theta. Take down called equation number 2. Now adding equations 1 and 2. Adding equations 1 and 2 we get, repeat same procedure, adding LHS and RHS separately, that is cosec inverse x plus sec inverse x is equal to theta plus pi by 2 minus theta. Plus theta and minus theta get cancelled out. So therefore write down remaining term, cosec inverse x plus sec inverse x is equal to pi by 2. Hence the proof of third properties. Next, prove by one inverse trigonometric functions to another inverse trigonometric functions. Prove by one inverse trigonometric functions to another inverse trigonometric functions. Another inverse trigonometric functions. Prove that the following first one is sin inverse 1 by x is equal to cosec inverse x. Sin inverse 1 by x is equal to cosec inverse x. Here x greater than or equal to 1 or x less than or equal to 1. Now second property, cos inverse 1 by x equals to sec inverse x. Here also same, x greater than or equal to 1 or x less than or equal to 1. Now third one is tan inverse 1 by x equals to cot inverse x. Here x belongs to R. X belongs to R. Sorry. X greater than 0. Its condition is x greater than 0. Next, fourth one is cot inverse 1 by x is equal to, its reverse, tan inverse 1 by x. Here also same, x greater than 0. Now fifth one is cosec inverse 1 by x is equal to sin inverse x. X greater than 1 or x less than or equal to 1. Now sixth one is sec inverse 1 by x is equal to cos inverse x. Now let us prove one by one here. First one is sin inverse 1 by x is equal to cosec inverse x. Prove by one inverse trigonometric functions to another inverse trigonometric functions is there. Means in the LHS also inverse trigonometric functions is there. In the RHS also inverse trigonometric functions is there. We have to prove one by one. First one is sin inverse 1 by x is equal to cosec inverse x. Now this implies take or let sin inverse 1 by x is equal to y. Take on called equation number 1. Now this sin inverse function move right hand side, it becomes sin y. Sin y. Can I write sin y is equal to what's remain? 1 by x. Sin y is equal to 1 by x. Now taking reciprocals on both sides, what will get? Reciprocal of sin y is cosec y. Cosec y. And reciprocal of 1 by x is x only. Here b, because taking reciprocals on both sides. Taking reciprocals on both sides. Again, now this implies y keep as it is there only, and this cosec function move right hand side, it become cosec inverse x. Cosec inverse x. Take it on called equation number 2 here. Now see the equation number 1 and 2, or comparing equations 1 and 2, we get LHS sin inverse 1 by x keep as it is. Now this equals to, put the value of y. See the equation number 2, y value is cosec inverse x. Cosec inverse x. Hence the proof of first property. हमें वही prove करना था. Now second one is same case, cos inverse 1 by x is equal to sec inverse x. Second one is cos inverse 1 by x equals to sec inverse x. X greater than or equal to 1 or x less than or equal to 1. Here also take or let cos inverse 1 by x is equal to y. Here also we have to take it on called equation number 1. Now repeat same procedure. This cos inverse move right hand side, it become cos y is equal to 1 by x. Cos y is equal to 1 by x. Now taking reciprocals on both sides. So what will get? Reciprocal of cos y is sec y, and reciprocal of 1 by x is x only. Here we taking reciprocals on both side. Now further, now this implies y keep as it is there only, and sec function move right hand side, it become sec inverse x. Take it on called equation number 2 here. Now comparing equations 1 and 2. Comparing equations 1 and 2, we get cos inverse 1 by x is equal to sec inverse x. This is the proof of second property. Now same case, we have to prove tan inverse 1 by x is equal to cot inverse x, and same cot inverse 1 by x is equal to tan inverse 1 by x, like this. Now continue. Now third one is tan inverse 1 by x is equal to cot inverse x. Let's prove it. X greater than 0 here. Now let tan inverse 1 by x is equal to y. Take it on called equation number 1. Now same case, tan inverse function move right hand side, it become tan y. Now this implies tan y is equal to 1 by x. Now taking reciprocals on both sides, we get reciprocal of tan y is cot y, and reciprocal of 1 by x is x only. Here we taking reciprocals on both sides. Now this implies y equals to this cot function move right hand side, it become cot inverse x. Take it on called equation number 2. Now adding equations 1 and 2. Comparing equations 1 and 2. Comparing equations 1 and 2, we get, so tan inverse 1 by x is equal to cot inverse x. Hence the proof of third property. Now same case, we have to prove the property 4. Fourth property is cot inverse 1 by x is equal to tan inverse x. Now this implies, first take or let cot inverse 1 by x is equal to y. Take it on called equation number 1. Now further repeat same procedure. This cot inverse move right hand side, it become trigonometric function. Inverse functions move right hand side, it become trigonometric function, and trigonometric functions move left hand side, it become inverse trigonometric functions. So therefore cot y is equal to 1 by x. Again taking reciprocals on both sides. So reciprocal of cot y is what? Tan y. And reciprocal of 1 by x is x. Here we taking reciprocals on both sides. Now this implies y equal to this trigonometric functions move right hand side, it become inverse trigonometric function, that is tan inverse x. Take it called equation number 2. Now comparing equations 1 and 2. Comparing equations 1 and 2, we get cot inverse 1 by x is equal to tan inverse x. This is the proof of fourth property. Now next, same case here also we have to prove cosec inverse 1 by x is equal to what? Sin inverse x. Fifth one is cosec inverse 1 by x is equal to sin inverse x. Here x greater than or equal to 1 or x less than or equal to 1. Now this implies take or let cosec inverse 1 by x is equal to y. Called equation number 1. Now this cosec inverse function move right hand side, it become cosec y is equal to 1 by x. Now again taking reciprocals on both side here. So reciprocal of cosec y is sin y. Sin y, and reciprocal of 1 by x is x only. Here we taking reciprocals on both sides. Taking reciprocals on both sides. Further simplify, y equals to the sine function move right hand side, it become inverse sine inverse of x. Sine inverse x. Now take on called equation number 2. Comparing 1 and 2 means equation 1 and 2. Comparing equations 1 and 2, we get cosec inverse 1 by x is equal to sin inverse x. This is the proof of fifth property. Now last one is sec inverse 1 by x is equal to cos inverse x. Let us prove this one also. Sec inverse 1 by x is equal to cos inverse x. Let sec inverse 1 by x is equal to y. Take down called equation number 1. Now same case, this sec inverse move right hand side, it become sec y is equal to 1 by x. Now taking reciprocals on both sides. Reciprocals on both sides, what will get? Reciprocal of sec y is cos y and reciprocal of 1 by x is x. Here we taking reciprocals on both sides. Now this implies y equals to this cos function move right hand side, it become inverse, means cos inverse x. Take down called equation number 2. Comparing equations 1 and 2. Comparing equations 1 and 2, we get sec inverse 1 by x is equal to cos inverse x. This is the proof of fifth property. Now continuation. Next, properties is there. Prove that the following. Prove that the following. Prove that the following. Sin inverse minus x is equal to minus sin inverse x. Now second one is tan inverse minus x is equal to minus tan inverse x. Now third one is cosec inverse minus x is equal to minus cosec inverse x. Let us prove these three properties here. Now, proof of first, that is sin inverse minus x equal to minus sin inverse x. Now here take sin inverse minus x is equal to theta. Sin inverse minus x is equal to theta. Take down called equation number 1. Again, this sin inverse move right hand side. It become minus x, keep as it is there only, minus x equal to sin theta. Now therefore minus x equal to sin theta means x equal to minus sin theta. Now here outside minus is there means negative. You have to cancel out this negative sign, means put its value, that is x equals to already we know sin minus theta equal to minus sin theta is there. Sin minus theta equal to minus theta means in place of minus sin theta we put sin minus theta. Outside negative is there, so अगर outside negative है तो और ये negative को हटाना है यहाँ से, so ये negative को हटाना बोले तो in place of sin minus theta, sorry, in place of minus theta we put sin minus theta here, means sin minus theta. Now again same, this sin function move left hand side, it become minus sin theta, sorry, minus theta is equal to sin inverse x. Finally minus theta equal to sin inverse x means theta equal to minus sin inverse x. Take it on called equation number 2. See the equation number 1 and 2, or from 1 and 2 means equation 1 and 2 we get Sin inverse minus x is equal to, in place of theta put its value, that is minus sin inverse x. Minus sin inverse x. This is the proof of this property. Now second one is tan inverse minus x equal to minus tan inverse x is there. Second one is tan inverse minus x is equal to minus tan inverse x. Now here also we have to take or let tan inverse minus x is equal to theta. Take down called equation number 1. Now same case, minus x keep as it is there only, and this tan inverse function means inverse trigonometric functions, move right hand side we get trigonometric function, that is tan theta. Minus x equal to tan theta is there, means x equal to minus tan theta. You have to cancel out this negative sign, means because tan minus theta is equal to what? Minus tan theta is there, already we know. In place of minus tan theta, we put tan minus theta. X is equal to, in place of minus tan theta, we put tan of minus theta. Tan minus theta. Same case, here we have to find out theta value, means minus theta is equal to this tan function, move left hand side it become inverse tan inverse x. Finally minus theta equal to tan inverse x, means theta equals to minus tan inverse x. Take down called equation number 2. Comparing equation number 1 and 2, or from 1 and 2, we get, from equation number 1 and 2, we get tan inverse minus x equals to, theta value is what? Minus tan inverse x. Hence the proof of second property. Now last one is, that is cosec inverse minus x equal to minus cosec inverse x. Now third one is cosec inverse 1 by x, cosec inverse minus x is equal to minus cosec inverse x. Now here we have to take cosec inverse minus x is equal to theta. Take down called equation number 1. Minus x keep as it is, this inverse function move right hand side it become cosec theta. Then finally x is equal to minus cosec theta. You have to cancel out this negative sign, means replace its value, that is because cosec minus theta equal to minus cosec theta. Cosec minus theta equal to minus cosec theta. Then x equals to, in place of minus cosec theta, we put cosec minus theta. Cosec minus theta. Now therefore minus theta equals to cosec inverse x. Now this implies theta equals to what? Minus cosec inverse x. Take it on called equation number 2. From 1 and 2, from 1 and 2, equation number 1 LHS is cosec inverse minus x equals to equation number 2. 2 is theta value is there, that is in place of theta put its value, that is minus cosec inverse x. Hence the proof of this property. Sir, cut ಮಾಡಕ್ಕೆ ಬರಲೇನ್ರಿ?